Hey everybody, I'm Greg Soul and I'm here with another CIQ demo. Today I'm going to be showing you how to automate Windows host using Ascender. So really I'm going to be taking a Windows host and going from 0 to 60 as fast as possible. So adding into the system and doing some automation. But before I actually get to turning knobs, I want to give you a little understanding of kind of how we actually connect to Windows host and all those pieces associated with it. And it's good to have friends. And today I have a special guest to help us do that. All right. So my special guest today is Jimmy Conner. I've actually had a lot of practice at saying this because I've messed it up multiple times, but he is a principal solutions engineer here at CIQ with us. Again, I've said this so many times to him already, but most talented engineer I've ever worked with, and equally most annoying, right? It's as bad as his jokes are, his talent outweighs that somehow, amazingly.
Gotta offset it.
Somehow you've got to do it. But also by far the most knowledgeable person I've ever worked with as far as Ansible, and he is going to tell us all about Ascender with Windows, the connections, kind of some of the underlying principles, some of the hopefully caveats, gotchas that you're maybe going to run into. So as per the quick start, let's get going, Jimmy.
Hi, so yes, I'm Jimmy Conner. I am a principal solution engineer at CIQ. I've been working for Ansible for about the last 7 years. I've touched just about everything with it, from Windows to networking to Linux. And the great thing about it is you can really connect to anything within here. So today we're here talking about Windows on Ascender, Windows on Ansible. And we're going to go through some of the basics of how connecting, what everything looks like, variables you may have to set, and how those connections generally go. So if you haven't ever seen a playbook before, this is what a playbook looks like. It doesn't look any different from the Linux side than it does the Windows side. You still have the same tasks. You still have the same different hosts you put in there, variables you put in. The thing that's only really different is you're using different modules. You're telling it to connect a little bit different. We don't show the variables within here. I have another slide for that. But generally, when you're looking at a playbook, the very top, you're going to have a name telling you this is what we're actually trying to do inside this playbook. Underneath that, we have our host, and then we have some variables, and then we have our task. You'll see we have two different tasks in here, one for installing IIS, one for creating the IIS bindings. We use the WinFeature module, so it's in the Ansible Windows community. So we use the WinFeature module to install the web server, and then we actually set up a SSL port on IIS with there. But it's not too different than what you do with pretty much any other playbook working with Ansible. Ansible can work with anything, and it works with everything virtually the same way. So the one thing about Ansible for Windows, though, is Ansible was originally written for Linux. It was developed to connect to Linux, so that's because of that, every single variable behind it, every single connection type defaults to all the Linux stuff. So the networking and the Windows stuff were added in later, and so we have to basically change all these different variables with here to say, hey, we're not connecting over SSH, we're not connecting with this root user or anything else, we're connecting to WinRail or these very specific ports to connect to Windows. So the 5 different variables we typically use are these. We have our Ansible connection. That's basically where we tell it we're not using the SSH, we need to use WinRail. And then we have an Ansible port one. By default on Linux, this is going to be port 22. We need to change that to either 5985 or 5986. One's the unsecured port, one's the secure port, and we'll talk a little bit about why you want to use either one of the others. Then we have a certificate one. If you don't have valid certs on your WinRail server, most people don't. I've actually ran in my last 7 years, I've probably ran into maybe 2 or 3 organizations out there that actually use valid certs on every single server. Most people don't. So we tell that to ignore that cert validation. They're all the self-signed for the most part. Then we have the WinRail transport. This is going to be the one important ones. This is what basically is telling us what authentication method to use. There are 5 different ones that we're going to talk about. And if we happen to use the Kerberos one, we need that very last variable, which is setting a delegation flag. We'll talk about why on that. So our 5 different authentication methods are basic, NTLM, certificate, CredSSP, and Kerberos. So by default, 2 of these are enabled on WinRail. Pretty much every single box is going to be NTLM and Kerberos. Basic itself is completely unencrypted. Now, the thing about the WinRail protocol is you have an authentication method, and then you have the WinRail protocol itself. The WinRail protocol itself is always encrypted. It doesn't matter what authentication method you use. The protocol is always encrypted, but the authentication method may not be. If you're using basic, that's basically sending your credentials over the wire to WinRail. Basically, easy to unencrypt, not really encrypted. You do not want to be using this. Most organizations won't allow you to do it, and you have to enable 2 different settings to even allow you to do this. You have to tell it to allow basic and to allow unencrypted. We didn't have NTLM. NTLM is on by default. It hashes it, but it's very weak. So again, it's not one you want to use in every day, but it is available. And it's very important that it's enabled by default because we're going to use this later to connect in and actually set everything else up we want. You didn't have certificate. Certificate itself, I don't really see any organizations out there using it. It actually uses user certificates. So you have to basically set up a user and then set up a certificate for that user on every single server. You have to make sure they're rotated, they don't expire, all that sort of stuff within there. It's really a pain to use. The one company I saw that really tried to go all in on the certificate one gave it about 6 months and then they stopped. They just moved back to the normal stuff. We didn't have the 2 higher level ones, which are CredSSP. So this is basically, it wraps it all in a TLS tunnel. So you have basically NTLS or Kerberos, and it wraps in a TLS tunnel, and it goes over the secured port. It has to go over to secured port. The other 3 that I just talked about can go over the unsecured, or technically have to go over the unsecured for the most part. The CredSSP one has to go over the secure port itself. We also have Kerberos. Now, Kerberos itself, it has to be on a domain to use Kerberos. What's happened is we're not really passing username and password anymore. We're connecting to doing a KNet, connecting over to Active Directory, pulling down a ticket, and we pass the Kerberos ticket ID. CredSSP and Kerberos are considered ones to fix the double hop scenario. So if you don't know what the double hop scenario is in WinterRealm or in Windows itself, it's basically where I'm connecting in with WinterRealm. I connect to the server. I pass, say on the NTLM, I pass my one-way hash to the server. It gets that. I'm authenticated to the server, but then there's certain things I need to do, like connect to a file share on a different server from that server to pull over an installer. Well, it's not caching those credentials to pass that along to the other server, so it tries to authenticate as anonymous, which then, fails. So that's what's considered a double hop, is where I have to connect to this server, and then from there to something else, I need to be able to pass those credentials in a secure way to where I can then pass that along to the next server. So CredSSP kind of fixes that. Now, there are some insecurities with it, and the fact that it is storing it on a local credential store on the machine. So if you are on that machine and get it right at the right time, you can actually pull those credentials out. And, depending on what you use as NTLM and it's less secure, then you can decrypt it. A little bit of hacking on there. But for the most part, it's stored in a credential store and then it passes it along to the secondary thing. Kerberos has the same thing. The key with Kerberos, though, is your Active Directory domain has to allow, first of all, you have to have that delegation flag set on the bottom down there, so that Kerberos delegation. If you don't have that, then it's not going to try to get a proper certificate that allows multiple machine access, because by default, that Kerberos ticket we get saying, I'm allowed to connect with this user to this machine, and that's it. That's what that Kerberos ticket gives us. That way, if someone else gets that Kerberos ticket, they can't really do much with any other machines with it. It can only connect to that machine. But when you have that delegation flag, it's basically saying, okay, I need a ticket for a user that can connect to any machine, so that it can pass that along and I can connect over to a file share or elsewhere using those Kerberos authentication. So again, that is itself considered not as secure, because again, I have this ticket, but you're kind of weighing the risks. I got to do automation. I got to be able to pass in credentials. What is my biggest risk? What's my lowest risk? What can I actually, use? But these are the 5 authentication methods in itself. Pretty much everybody out there today uses Kerberos or CredSSP. So you're using Kerberos if it's on domain. They use CredSSP if it's not on the domain. Within here, they'll use NTLM to then set up. So basically, by default, NTLM is on. So they'll connect in over the unsecured port, because by default, the unsecured port's on. Connect to NTLM and say, okay, I need to join this server to the domain. We'll join to the server with the domain with Ansible. Once it gets on the domain, then they'll swap over to either the secured port and swap over to Kerberos. Now, there are reasons why you may want to use Kerberos with the unsecured port, and I'm seeing most of the organizations out there today are using that, because again, the Kerberos itself is fairly encrypted as far as its authentication protocol. It's only allowing me to connect to this one machine with it. You're not going to do much with that ticket ID. The secured port itself requires a little bit of setup. You have to set up search. You have to do a lot of stuff on there unless you're doing self-sign. So a lot of companies don't want to enable that secured port. And instead, they go Kerberos over the unsecured port because the WinRM protocol itself is already encrypted. So when you stick it over the secured port, you're doing encryption on encryption. Where's the benefit of that? So I'm seeing a lot of companies out there today that do Intel Elm, set up Credus P if it's not on the domain, Intel Elm, and then get it on the domain and use Kerberos if it is on the domain. So that's the 5 different authentication methods out there.
Yeah. Let me ask you a question about it. So you said WinRM is encrypted, which is great. Do you know when the authentication process happens? Does it authenticate first and then start passing traffic over WinRM? It happens first. Okay. So that really does make it important, like for like basic or NTLM, that authentication is going to happen not through the WinRM tunnel, but that's going to happen just kind of over the wire, and then WinRM gets set up and
with WinRM itself, you can think of it, you're really doing an HTTP protocol. So when you're sending that credentials, you're sending it first.
Okay. So yeah, that was a kind of a key point that I even myself, I was a little unsure about, because I was thinking, well, if this is a secure tunnel, it shouldn't matter, right? If you're using kind of NTLM or basic, because it would be over that encrypted tunnel, but it's not. So that happens first. No, it's
not.
All right. Excellent.
Yeah, and then from that, so these variables you have here, you're generally going to set them up in a group inside your Ansible. So I see a lot of people, they try to put these at the beginning of their playbook. And there's sometimes I will do that. So like, for instance, my playbook I use for setting up the server to get it on the domain, I put my variables at the front because I'm specifically telling it I want to use Kerberos. And I want to force that within the playbook, NTL Elm, because I want to force that in the playbook because I'm connecting it in a realm. But then inside my inventory, I have a group, say, called Windows, that I then stick my variables on there and have Kerberos, because everything on my domain, everything in my network is on my domain. So then I'm always connecting in, forcing that Kerberos connection anytime I connect within them. I just override it at the playbook level for my provisioning playbook.
Yeah, and that's an excellent point, right? So you shouldn't be putting these variables in every playbook. Even then, in your inventory, you have multiple places you can put variables, right? You shouldn't be putting them right on an individual host, right?
Yep. Yeah. I do it at some type of group level. So I generally just I may have 2 different groups within there. I may have a Windows group, and then I'll have a Windows non-domain group, just since it's the minority, and then throws things in there for, CredSSP, etc., for connecting those type of servers. But for the most part, all this stuff just goes in a group, and then I just apply that group to all my servers, or when I pull it down from, say, VMware, I actually have that group in there until it override. So it makes it pretty handy.
All right. So one last tip. Security teams are going to see these authentication methods, right? They're going to say, oh, certificate based. We would definitely want to use that. What ammunition can you give our ops engineers here to hand over to a security team that says, hey, certificates, a bad idea, that you're just going to have a bad time? Like, what's the best way of explaining to them?
I would say the best way of explaining is just the amount of work required versus the amount of extra security you get from it. It's not really a lot there. I mean, really, I would probably say lean more towards telling them, hey, well, certificate, yes, but if this account gets expired, or say this certificate gets, compromised, that means I have to go to every single machine individually and change that certificate out, versus if we use Kerberos, it's a single flip. You do it in Active Directory. That would be the biggest thing. Usually the biggest fight is not with, say, the certificate one. With your security teams, the biggest fight is they want to run everything over a secure port. And just the amount of effort it takes to set that up and set up certificates with, the CA and everything else, it's just a big headache to get all that to work. When really, and there's a page on Microsoft's website that shows all this, that, hey, this is already encrypted. The WinRM protocol is already encrypted. So as long as you're using a secure authentication, going over the default unsecured port is perfectly fine according to Microsoft.
All right. Awesome. Well, Jimmy, this was awesome, as always, enlightening, and I always learn something new every time I hear you talk. So I would encourage everybody, every time you see Jimmy doing something, please join in. So thanks, bud, and we'll see you again soon.
Yep.
All right. And again, thank you, Jimmy. So let's get started. So first things first, I've got a Windows host and I need to add it to an inventory, right? Inventory is going to be a big list of all the things I could potentially operate against. So typically I'm going to go to add and add inventory, and that will create an inventory. I've already created one for this lab, so I'm just going to show it to you really quick. The next thing we do once we have created the inventory is we need to add hosts to it. So you see I've got a couple of hosts in here, and I'll click on this one specifically because this is the one that my playbook's going to be operating against. So if I click edit, it actually allows me to change things. So if I click add and then add a host, this is the menu I'm presented with. I will give it a name. So Greg Win IS1. And theoretically, if that name is fully qualified and so basically what happens is Ascender will fire the automation and then it will try and look up the name of each host, right? And if it is fully qualified, we're done. It doesn't have to do anything else. But mine are just in a lab environment. They aren't. So I add something called a magic variable. And a magic variable is one that is just known to Ansible, and it has a special purpose. And this one is Ansible_host that says, hey, if I've got this variable created for an individual host inside of an inventory, use this IP address. So I've done that. Now, technically, we are done adding that host, but as Jimmy told you, we actually have to add some additional variables to tell Ansible to connect to this thing, because by default, it's going to assume it is a Linux server, and that is absolutely not how we're going to be connecting here, because we're going to be doing it via WinRM rather than SSH. So we can add those variables at the top level of the inventory itself. And so this one is for Windows hosts only. So that actually would be a viable option. But more traditionally, you're going to create a group. Say right here, I've got Windows group. And I'm going to add those variables into the group itself, right? And then I'll go under the group, group. Then I'm going to go into hosts, and I've added those individual hosts. But for this group, Windows, right here, you can see I've got the connection type. I'm telling it it's WinRM rather than SSH. I'm setting up the schema stuff. I should be using transport of CredSSP or potentially Kerberos. Here I'm using NTLM. And remember, Jimmy talked about you can start with NTLM because that's on by default, and then connect into the host, configure the Kerberos, right? So you could add it to the domain and then switch over to Kerberos, whatever you need to do. But for just this demo, I'm just going to be using NTLM really quick. So now any of those hosts are going to inherit all of these variables. We're good to connect. Next thing we do is we add a project. So let's add, and then you just fill in the blanks right here, right? I'll give it a name. I'll choose Git, which is going to tell it, hey, this is pulling from a Git repository. And again, a project is how you pull in all of your playbooks, your templates, right? All of your accoutrements associated with your automation you're trying to run. Right here, you're just going to put in the source control URL and then the credential to log into it. I've actually already got one right here, Greg Soul Windows. Again, I'm going to have a blog post that's going to outline most of these details, so don't worry overly much about trying to screen scrape everything you're seeing here. We'll have some stuff associated with it. But here you can see I just put in my public Git repo. That's why there is no source control credential, because it's open to the public. You can grab all this stuff as you want. So as soon as I add that, it's going to synchronize, which means it's going to pull in all those materials, and then we're good. Next, credentials. How are we logging into this thing? So I created a machine credential, and again, it's add credential. You choose machine, you fill in the blanks. For mine, I am just doing the administrator, and then with a password, right? You've got all these extra options. You can change privilege escalation to run as for a Windows host if you want to. Once we have that credential, we're done as far as logging into the machine. Now, the automation I'm running here actually does something pretty interesting. So it's connecting to my VMware environment and doing something special. So I had to add an additional credential in here. So I've created a custom credential. That means you can create a credential type down here in credential types that allow you to prompt the user for any kind of information you want. You can designate certain things as secret. Now that information will get pushed into, say, either the execution environment, like as you're running the automation, it'll go in as an environment variable, or generally what I do is I pass that information in as an extra variable at runtime, right? So it'll just pull in and overwrite any other variables that maybe have that exact same name, but ultimately it's just in there and I can utilize it. So I've got my VMware server connection credentials right there as well. Next, we're going to go to the template section. This is where we bring it all home. All of those constituent pieces kind of come together. So I've created, and again, it's add job template. So I've created a job template called Windows Update with Snapshots. So I'm going to click Edit. In this one, I've given it a name. I chose the inventory, which is my Windows Lab inventory. I chose the project, remember, which is our Git repository. It's going to pull all of that stuff in. And then I chose the proper playbook in there, Win Updates. Next, I went to credentials. I added my VMware Cloud. So really, I went into a generic credential and I added the VMware server. So I've got that. I wanted to actually add a machine credential. So then I just hit the plus and it defaults to machine right there. And then I chose the Windows Administrator, said select, and it populates those two boxes. After that, I added some extra variables to my playbook right here. That's going to get passed in as extra vars. And what extra vars are those that are injected at runtime, have the highest level of precedence, so it's going to override anything that's in that playbook. Next, I click save, and I'm ready to run this playbook. It's really just that fast. So I'm going to go ahead and click launch. And while it does that, I'm going to pop over to the playbook itself. I'm going to give you a quick breakdown of what's going on. So in the playbook, again, in a public repository, so all this is available to you. You can see up at the top, I have the vars section. So these are just going to be extra variables that I can put in here. And generally, I'm overriding all of these at runtime. Now, why do I even put them up there if I'm just going to override them all? If you have all of your variables at the top in the vars section, it's kind of easier to remember what's there and available for you to change. So it's really just kind of a nice to have. Now, what this playbook is ultimately doing is it's doing updates on a Windows server, but it's doing it in an interesting way. The very first thing it does is it uses the community.vmware.vm guest snapshot module, right? And so what it's doing is it's connecting in and it's taking a snapshot of this machine. Next, it's going to pop down here into a block, and a block is just kind of a chunk of modules that are going to be running on their own, or tasks, more specifically, a task that actually fire off modules. But what it's doing right here is it's going to do the Windows update. Here I have it state search, so it's just going to do more like a check mode. It's just kind of look up. In a real environment, you would have it actually make your adjustments in there. The next cool thing is if these updates fail for any reason, it hits this rescue section, and guess what it does? It rolls back the snapshot. So it undoes all the changes you just did. And then if it completes successfully, it'll go ahead and delete the snapshot as well, right? So it actually comes back in and does cleanup. I've got it in here, a couple of debug messages for showing you if you did have a monitoring system, you could actually, previous to making these updates, you could have it put it into maintenance mode and then pull it out of maintenance mode. Kind of gives you some options there. All right, now that I've popped back over to Ascender, you can see that the playbook has completed. And I'm going to take a look here, and I can see all of my output. So I can see create the snapshot. You can see it says change. That means it actually made an adjustment. There's this concept of item potency inside of Ascender, right, in Ansible itself. And the idea is I'm really defining state. I'm saying make whatever this thing is look like this. If it looks like that, do nothing. You'll see the green where it just says, okay, I didn't actually do anything. I didn't make any changes. If it looks and says the state needs to look like this and it doesn't, it will actually make the adjustment and it'll say changed, right? Really cool key function of using Ansible with Ascender here. Now, any of these things that say changed, I can go in and I can click them and it will give me additional information, right? Very different than running things on the command line. It'll actually tell me very specifically what's going on there. So the updates, if I was actually applying these, this would be orange and changed. But for now, since it's in the exact mode it's in now, where it's more just kind of a check mode, I can click on it and I can see all of the updates, right, that were security specific that I would have installed. So as you can see, you can get up and moving, doing some really functional things in Windows servers very quickly. If you have any questions or comments, or you tweak or tune this, I would love to hear about it. If you have any questions about Ascender itself, we'd love to hear from you as well. And if nothing else, happy windowing, happy ascending, and we'll see you next time. Bye.